Hey kids, welcome to lesson 4, using simple commands. This lesson is going to serve as an introduction into the App Lab. This is our integrated development environment, or our IDE. And really what we're going to do today is pretty simple, kids. Let's start off by talking what we see here. If you look over here, this is going to be the output of where our app is. So anything we code, it's going to come over here. Now this little thing here, this thing's called a turtle. And why it's called a turtle is way back in the day, we used to have these computers that drew things on the floor that you could program, and they kind of look like a turtle. If I'm a good teacher here, you'll see a picture of one pop up so you kind of know what I'm talking about. You're going to hear me refer to this a lot as Badgie. If any of my Lower Deck fans out there, shout out to you kids. It's always looked like a Star Trek communicator to me, so that's what I kind of slip into sometimes, but we'll see how well I do. Our turtle's going to move around the screen based off of our toolbox or our commands here. And these commands, right now we only have 4, but as we go along and progress through the chapter, we're going to have a ton of them. But for right now, you get 4 little commands. Move forward, turn left, pen up, pen down. We'll talk about them all in a second here, kids. Moving down here, this is our console. We have a little turtle rabbit over here. This is basically the speed in which this turtle will move. Kids, it can go really slow, so cranking up the volume here sometimes works very well. The other thing down here is the Debug Console. A lot of times in coding, we need to print stuff out. We might not necessarily want it in the app over here. We just want to know if our numbers are correct or if something's happening in the background. In that point, we can print it out, and this is where it happens down here. Little clear button. Kids, you can manipulate everything in here too, by the way, with the 3 little dots. Same thing here. This is going to be our workspace, where we're going to code at, kids. Whenever we code, code.org automatically saves for us. And if we hit version history, you can see we can call back anything. Even saves back to my last year class right there. Show blocks. Well, this is going to be pretty helpful, kids. When we get into coding here, you can either do a text-based or a block-based. All of this is Java. Difference is one has syntax, one has taken that away. And syntax is simply the parentheses and semicolons and everything else. You can use whatever you want, kids. I will mostly do this in text because that's really what I'm used to. And you'll notice whatever bad habits you develop in this class, you'll probably take it for the rest of your coding life. You can do either or, like I said. I would try and push yourself and do the text. But again, if you're worried about just getting through the day, the blocks are perfectly fine. In each lesson here, we are going to have some instructions and do this. Usually we have some helpful tips. Most of the time it's a video. Sometimes it's some example code. You kids don't get this. That's our solutions. Always though, first thing you're going to want to do is read what's in here. So let's figure out what we're going to do today. Given only 4 turtle commands, write code in App Lab to complete the drawings in each of the following challenges below. Your goal is to write code that solves the problem as efficiently as possible using only the commands provided. What does efficient mean? In computer science, it can actually mean several different things depending on what you're talking about. Work on these challenges, try to solve them in a way that you think is best, and we'll ask you about efficiency in the end. And kids, this is one of those terms you're just going to hear a lot. We have our first challenge here. Do this. Draw a 1x1 square to the front and left of the turtle as efficiently as possible. The program should stop when the turtle is in its original position. Once you think you have the solution, click the finish button. It will appear once you run the program. All right, kids. Let's talk coding here. Move forward here is going to move our little turtle forward. We don't have any parameters or arguments to that yet, so it's going to move a specified distance. Usually, that's 10 pixels. Turn left, we'll do just what that says, turn our little turtle left. Pen up and pen down. This goes back to what I was talking about earlier, those giant turtles that would go on the ground and draw pictures. We had a command pen up and pen down that literally picked a pen up or put a pen down. That lets us draw things on our app. That's how we're going to get that little square in there. Just as a note, pen up and pen down is just that. It's not a distance measurement. You can't do pen up 10. That doesn't mean anything. When we get down the road, I just want you to be aware of it. Very common mistake I see with the kids. Over here, we have a little example. And you can see we got the turtle goes up, forward, down, forward, up, and then another turn left. So that's pretty simple. For our first one, we're just going to drag some blocks over. But again, kids, you could simply do move forward. And you'll notice as we start typing, it'll finish our command. Right now, we only have 4, and that's the only option will come up. As we go along, though, once you type the word M, a whole bunch of commands are going to come up. This is going to give us an option for parameters. Again, like I said, right now, we're not worried about this. We only have 4 things. In the future lessons, we're actually going to specify the distance to move, but for right now, we're not going to worry about it. Semicolons are like periods in the coding world, kids. Make sure it's after everything. So we're going to move forward. Then, kids, we're going to turn left. You can see it also auto-fills in. So once you put one parentheses, the other one comes in. And then we put another little semicolon. We're going to move forward again. Oops, didn't want to put a number in there. You see the little yellow triangle coming up here. This is going to tell you any errors that you have. Right now it's telling me I'm missing a semicolon, so I'll give it a semicolon. We're going to turn left again. Then move forward. Watch your spelling here, kids. If you see a uppercase or lowercase m makes a difference. And remember, we talked a little bit about this before. This is an actual camel case. That means a lowercase for the first word, uppercase for every word after that. Why do we do that? Because there's no such thing as a space in coding, kids. So you have to distinguish words somehow. And that's just one way to do it. We're going to do another turn left here. Trying not to put numbers in there. So we're going forward, left, forward, left. Let's see that again. We're going forward, turning left, moving forward, turning left, moving forward, turning left. We got to move one more forward and one more turn left. You can see, kids, where you could get some errors in spelling here. So again, blocks are perfectly acceptable. I think I'm pretty good here. I can go ahead and hit the run button. And we're going to see my little turtle go. Go, turtle, go. As you can see, this is really slow, kids. That's a little faster. We ended in the same position. Oh, that's the correct way. Let's see the turtle go a little quicker. There we go. You also notice when the code runs, it'll highlight whatever line it's on. This is very helpful when we're going to debugging and seeing where something runs into an error. Just something to be aware of as we go along. I think we did what we had to do with this lesson. We drew a 1x1 square, turtles in the same position. I think we can finish. Let's see if code.org is going to let us. Yay, good job, kids. Let's head to the next one. Let's read our instructions, kids. Do this time draw a 1x1 square to the front and right of the turtle as efficiently as possible. Notice that there are no commands to turn right. You need to figure out how to draw this by only turning left and moving forward. The program should stop when the turtle is in its original position, facing its original direction. We have a little picture. Again, it's going to go this way. And once we're done, we're going to click the finish button and move on to the next problem. Now, kids, I know what you're thinking here. I got some smart kids in this class. Thinking, Mr. Rhodes, I know we only have a turn left. But obviously, I can spell, right? I can just write turn right here. And that'll take care of it. Well, kids, code.org has thought of this. You're limited right now to what you can do. It won't let you do anything that's not in the toolbox. So, kids, you're going to have to do this the way they ask. Let's go ahead and reset this. Clear out that. And let's do our turn left now. That's going to move it once. I think, kids, well, I think it's going to need to go 3 times. Let's see if that works. There we go. I think if I copy some code here, reset, run it. Look at that little turtle go. I think we might need to pick the speed up here. We're down here. I think we can reset it. Do one more time. Speeds up. Let's see this turtle move. Look at that turtle fly. One more move forward and turn left. I'm going to copy a extra turn left in here, kids, because I want my turtle the same way. Let's reset, run. Look at that turtle move, kids. Kids, you got to be careful when you're copying and pasting. Sometimes you can get stuff out of order. So be careful. Again, don't let my bad habits become your bad habits, kids. There we go. Ran through this time. You can see the turtle ends in the same way. Everything looks to be done correctly. Did exactly what we needed to do. Our pictures look the same. Let's go ahead and finish. Yay! Good job, kids. All right, kids. Well, this is a fun one. Do this. Draw a 3x3 grid to the front and right of the turtle as efficiently as possible. The turtle should end at its original location, facing its original direction. Here's our little picture of our turtle in the grid. You can see we have to figure this out. Hint, this problem presents some subtle challenges. Work with your partner to discuss possible solutions. Try more than one path. Test your idea on paper might be a faster way to brainstorm. Kids, that is an excellent hint right there, and I just want to take a moment and talk about that. Really, anything we do in coding, we should really plan out. Just like when we build a house, we need a set of plans. Or when we are building a furniture piece from IKEA, we need plans. So too in coding do we need those. Usually jumping in headstrong, well, that's a great thing to do with some problems, but poorly thought ideas get you back poor solutions. Kids, you're going to hear this term in coding a lot. Junk in gets junk out. Might have some more creative language in there with some other coders you meet. Whole point of this, take some time, think out the problem first before you go in. Do you think I'm going to do that right now, kids? Let's jump into it. Let's drag some stuff out here to get started. I'm just going to move forward 3 times here, kids. I think what I'm going to do is I'm going to go up, down, over, down, up, down, over, down, and I'm just going to kind of snake around like this. I'm going to make a bunch of those fun S's, kids, that you used to do in middle school. Once we get up there, we're going to turn left. Kids, that's going to turn us that way because you know what we got to do now. We got to do it a couple of times. Woo! Look at that spelling, kids. You're going to learn I'm a terrible speller. 3 turn lefts right there. That should get us over there. Let's go ahead and just copy this in and paste that down. Let's crank up our speed. Let's see where we're at. Looks pretty good to me so far, kids. Do some more copying. Well, no, I want to go down once now. So we're going to go move forward. Don't forget to reset, kids. It'll give you an error. That's going to take me down there. I think I can do 1 turn left. And then 3 move forwards here. And that should take me right over there. Should, kids. Should. Let's run it and see if it does. Whoa. That did not, kids. Looks like we need a couple more turn lefts in that one. That's pretty good. I think right now I want to go down here, over there, back down here, and then I can start snaking around like I wanted. I'm going a little backwards than I originally thought, but that's okay, kids. We can be flexible. Let's do a turn left here. Reset run. That's good. Let's move forward once. Reset and run again. I'm going to keep my turtle up here and keep going. I'm going to turn left another time here. Don't forget between semicolons and colons. Turn left here, and then I'm going to go forward 3 times again. I think that's around where I should be at. Let's reset run. Pretty good, kids. We're going to have to turn a bunch of times left again. Let's copy 3 in here. That looks pretty good. I'm going to have to go down here. I don't think my plan's working. Should have definitely gone up there to get that one. I'm going to be missing that, kids. Let's take these 3 away. Let's see what we can do here. Let's do a turn left, move forward here. We have to get this in. This isn't going to be efficient, kids, but it's going to work. Well, that looks pretty good. Let's do a couple turn lefts. There is some good coders out there watching this who are just cringing by what I'm doing. Kids, if I gave you the answer, life would be too easy. We're sitting over here. Let's take away 2 of these and see what happens. There we are. Let's go down to the middle here. Let's move forward once, let's say. And then, yeah, that looks pretty good. We'll go down, turn left. Whoa, kids. Our code went away. That should take us down there. We can go down there. You see, we're going to miss a ton of spots here, kids, but that's all right. We actually should spin left a whole bunch of times here. Let's see what happens here real quick. Yeah, I think we should spin around and go up. Kids, this lines of code are going to be like 300 lines here by the time we're done with it. Maybe I'll do one of those fun fast forwards where I just plow through the video right to the end. Woo! Kids, welcome back. This is the opposite of efficient, kids. 66 lines of code. Woo! We could have probably done this in like 30 if we wanted to. Either way, though, this is a solution if you're running into some issues, and just should show you that how you can just plug and chug along sometimes. Our drawings look together. I think this is all code.org wanted from us. Congratulations, kids. You just finished your first coding. Great job. Everything else, honestly, kids, is downhill from here. Well, that's it for this video. But you know what? I'll see you on the next one. See you later, kids. Bye, bye, bye.